you definitely have to use it to solve the question, okay? So if there's some information like this that you don't use one, right? Maybe you have to suspect something is wrong, okay? Yeah, but sometimes, right, they will just say that just to make the equation or the expression valid, okay? So sometimes this, right, is just to make the equation or expression valid lah. What do I mean? For example, if they give you y equals 2 over ln x minus 3, right? They will tell you x is greater than 3. It's to make this valid lah. If they are not asking you to prove anything, right, then they state that x, x greater than 3 is to be mathematically correct when they give you the question lah. Alright, now the diagram shows a circular field or radius whatever. Okay, so this is a circular field of radius 90. Very important, everybody. Okay, now whenever we do circles, right? Okay, remember I always swing my arm in class. This is my arm, and then this is the tip of my finger, right? Anywhere from the center here to anywhere here is the radius. So you must be strategic in where you draw the radius. They tell you that the radius is 90. Do you draw the radius here? Here? Okay, so here, of course it's not a radius, but you draw here, actually useless, useless, okay? It's always good to draw to the vertex. Why? Why vertex? Because later, right, once you draw to the vertex, you draw here, you can get a right angle triangle. That means you draw to the midpoint of PQ, you can get a right angle triangle, and then you can use Pythagoras theorem. Okay? Or you can draw here. Then you can get a right angle triangle using this radius 90. Okay? So must be strategic. And you cannot leave your diagram blank. Alright? In the prelims, some of you left your diagram. You draw the diagram, you draw the circle in the circle question, but then you left that whole diagram blank. Then might as well don't draw the circle, you know what I mean? Okay, so let's start. Okay, I don't know where to draw yet, but I bear in mind that, okay, this radius is 90. So annotate your question. Annotate means you do some doodling. Okay, then this view is the shape. Okay, this one nothing one. Okay, they're just trying to tell you they all lie on the circumference. Given that O is the center, okay, there's a center O, such that PQ equals 2x. Okay, PQ equals 2x. Okay, very good. Very good. Okay, then QR equals 2y. Okay, very good. Show that the rectangle is like that. Area of the rectangle. Okay, area of the rectangle, you know, is length times breadth, right? Wait. You see here got square root, whatever, right? Very likely, you know, from our experience in plane geometry, very likely is Pythagoras theorem. You apply Pythagoras theorem, right? Okay, so we know that this is 90. Okay, we know that this is x. We know that this is 2y. So this must be halfway, must be y. So this must be y. This must be x. Can you see? So you need to be strategic and draw your radius at the correct place. If you draw it the wrong place, right, then wrong already. Okay, so by Pythagoras theorem, isn't this the answer? Okay, and you get two possible answers, right? So since length is greater than 0, then I say I take the positive value lah. I reject the negative one, in other words. Okay, now the area I can write here length times breadth, because this is a show question. Okay, never mind, it's length times breadth, sorry, length times breadth. Okay, then throw in here, this one throw here, then I get the answer already. Okay, now this is because you have 8100, but what they want you to show, right, is 16 something, right? 16 something. So you just factorize a bit, and then you can get the answer already. Meaning to say you square this, right? Then you throw inside, then you get this already, because when you square root 16, you get 4. Square root this, you get this. Okay, so that's what they want you to show. Alright, now the next part is they say given that this can vary. Whenever they say things can vary, it means you can differentiate with respect to x. Okay, if they say t can vary, then differentiate with respect to t lah. So find the value of x in exact form. This one important. Can you box it up? You don't box it up, right? Later you may forget to. They may forget that you have to live in exact form. Okay, for which a is stationary. So you need to find the stationary the dA dx lah. And hence find this value of a, and then later to find the value of a, whether maximum or minimum. Okay, so now we transform this into a form that is easy or able you're able to differentiate. Okay, so I transform it into the form a is 1 x big x later to differentiate inside to the power n. Okay, power bring down, this one don't touch, power -1, now differentiate the inside. Remember, very importantly, you must put the brackets. You don't put the brackets, we will not mark you correct. Okay, actually it's not we lah. Now moving forward is the O level, the Cambridge examiners already. So this is you throw it downstairs. Okay, then half, right? You times half here, you times half here, you will end up with this. Okay, then you can still take out 32, and of course here, if you refer to the previous part of the question, you see, you can actually take out the 4x here, right? So the 4x, right? The 4x can actually cancel 32x, and you will get this 8 here, and that would be a very simplified form. Now, for stationary point, you have to go and find dA dx equals 0. So that's what I'm doing now. Now, this part here, you can think of it as when you cross multiply, this part is actually multiplied and it becomes 0 already, right? Okay, because this can never be 0, so you cannot equate this to 0. Only the numerator can be equated to 0, and that is what I get. And because there are two possible answers, I choose the one that is positive because this x is a length. So this is the x value in exact form. You see, the one exact form in which a is stationary, and then now you're supposed to find the stationary value of x. So I substitute in and then I can get where's my answer? Okay, I left out this answer. So can you go and work it out? Okay, I think can be done. If you're not sure, you check the answer with me. Okay, so that's all for number 8. Number 9. Yes. So now we go to number 10. Number 10 is a binomial question, alright? Now, binomial, I can tell you, very fixed. Okay, very fixed one. The working all very fixed. You either expand a bit, then compare terms, expand, compare terms, or you use the r+1 term. Okay, when to use the r+1 term? Now, you take a look. Given that there is no independent term of x, the term that's independent of x is something x to the power 0. Okay, so when there is no term independent of x, that means this is 0 lor. Okay, that means there's no constant term lah, no number. All the terms come with x 1 over x, x squared, whatever. Okay, anything but a number by itself lah. Okay, find the integer value of p. Okay, so this p is unknown to us. But they give us the hint. This is the hint that there is no term independent of x. Okay, now you ask yourself, do you use the r+1 term for this question? Must we use r+1 term for this part here? Of course not. We learn in Sec 2. We practice so hard. I believe you practice very hard lah. You practice very hard and you're able to do this, right? Must we use the r+1 term here? Okay. Actually, do we need to? You can if you want. Alright, you can if you want. Listen carefully. Why do I say that? And why do I do this? Okay, you see. I do this because I see here, power 0, power -1, power 1. But then I know that when I expand this, I can get power 0, power x. This and this will give me a constant term, right? This and this will give me a constant term also. Okay, this and this, that means this times this give me constant term, this times this give me constant term, this times this give me constant term. And when I multiply this 1, 2, 3 pairs together, I should get 0. You see, this time this is this. This time this is this. This time this is this. Okay? So I did it without constant term. But if you are not sure, right? If you don't know, I know because I one look I know lah. Huh? And because it's a very simple thing, I know that it's from 1 2 3 okay? But if it's like P over X here, then I cannot do this. Because if it's P over X, right, I can never get power 1, power 0, power 1, power 2. Do you understand? So because this is a very simple expression, I know that I don't need the R plus 1 term. I can very quickly use this. Okay? But if you have things like P over X here or P over X square here, I'm talking about this term, or X plus 1 over X or whatever, that means it's not not so simple one, then you use the R plus 1 term. Are we clear? Okay, but if you had used the R plus 1 term for this question, perfect. You will get the same answer as me, okay? Now I've done this already, I'm going to find the P. Oh, so I found that P is either this or this. Correct, right? No, wrong. Because they want the integer value. So things that are important, you may want to box it up, okay? But some of you underline already, right? Then later later you also don't reject one. So you must not do for the sake of doing lah, okay? So once you do more, you'll be getting a hang of it and then you'll be fine. Okay, we are done with this number 10A. Now we do 10B. Now 10B, should we expand all the way or should we use R plus 1 term? Now the answer of course is to use R plus 1 term. R plus 1 term, we are looking for a specific term. Okay, specific term without having the hassle of expanding everything. Now in the O levels, there are people, right? Okay, I tell you the story, then you just look at the solution. In the O level, there are people who expand everything, right? And they also get the correct answer, but it is inefficient. And they are wasting time in the exam when it's so precious the time, okay? So n plus 1 term, very simple one. You just choose, okay, you don't have to write like that. If you can alternatively write 12R, okay? 12R, same, is the same thing. Okay, now what we need to know is 12R already, right? Then this first term, okay, you put here. Second term, including the minus, you put second, and then you must put bracket. Now, this minus this will be your first term here, and then this one throw there. Very simple one. That means you don't need to refer to formula sheet. Okay, don't waste time. This whatever number is here, throw to this term. Then in between is 12 minus this, because this power plus this power must add up to 12. Okay. So after that all your numbers group to the left, your algebra to the right. Okay, and you simplify like that. Okay, so how do I see? Can you see the minus? I actually let it follow this fella, and you only follow one of them. Don't put the minus here and then put bracket. No, it's a wrong move. You throw it to the numbers. Okay, so after you have done this, right, we want power 3, right? So equate this to power 3 and you get this, and then you will get the answer already. And because they only want the coefficient, don't leave your answer like that. You leave your answer like that, you will not get the full marks. Okay, now we are going now to the second last question, I think. Patient, okay, you read. Okay, so this fella is monitored over a period of 12 hours and can be modeled by this equation where T is the number of hours after 9 a.m. Now this is important because, right, this T here is the number of hours after 9. It is not the time, like if I get 2, it's not 2 a.m. or 2 p.m. No, this 2 is 2 plus this, if you want the time of whatever happening is whatever is happening, right? Then let's say your answer is 2, then ask you what time did it happen, then it's 2 plus this is 11 a.m. Okay, I hope you are clear about that. Okay, now the first part, find the initial pressure. Initial pressure at 9 a.m. Because T is the number of hours after this, right? That means they're asking you for T equals 0. Hope you understand. Okay, so you sub T equals 0, please remember to be in the radian mode, not degree mode. This is pi whatever one, right? Is radian mode. Okay, and also for differentiation integration, it must be radian mode, and you must put the unit because this is an application question. Okay, now next, the highest power. So the highest possible blood pressure reading at the earliest time it occurred over the period of 12 hours. Okay, this one they're asking you for the greatest pressure and the earliest time when it occurred over the period of 12. That means when is the first x, the t value, what is the smallest t value? Because the earliest time down here means the smallest t value. Because you know t can have a few values, right? Later when you solve, can have go 1 round, 2 round. They want the smallest one, okay? So what you do is you look at this, look at this. Oh, very simple. This fella, we know just the cosine alone, I don't talk about all this, is from 1 to -1, right? Maximum, minimum value, okay, so I can have -1 here, then this will be the greatest already. That's why this is the answer, alright? Now, for the x value, then it is a little bit more work. Because we need this cosine, whatever, this whole thing here to be negative, right? Then you set it to negative. And when you set it to negative, this is the answer. How do I get this? Again, if you are familiar with the graph, this is the y equal to cosine graph. This is 1, this is -1, this is 2 pi. So when will it be -1? Is when it's pi. So just write here, finish. Okay, t equals to 3. So the earliest time, this is the earliest time, you see. There can be other times other than this. Can you remember? Go 1 round, 2 round, whatever. So the earliest time is 12 noon, finish. Okay, now next, they want you to sketch. Now how do you sketch? How do you sketch this graph against this for this? Okay, so you first of all, I write the equation here. Let me see what's the equation. The equation is this. Now, when you sketch graph, I want to remind all of you how to sketch graph. Firstly, do the middle line. Okay, the middle or the center line. So I have done that already. I do like that. Okay, after that, what is the amplitude? Now remember, the amplitude, right, does not include this minus sign here. The minus sign here only tells us whether your graph is flipped or not. Alright, so the amplitude is 30. So from 110 I add 30, that's 140. I label here 140. Minus 40, 110, so the 30, sorry, I said 40. 30, this like that. But minus 30 is like that. So this is correct. Okay, then after that, you look at your period. Okay, period is equals to 360, which is 2 pi over this whole thing right now. This whole thing, you must be very careful. It's pi t over 3. So the t is the variable. Alright, we want the whole constant. So that's pi divided by 3. Okay, now you have a fraction in the fraction, so you flip this. Okay, some of you still not very clear how to do this kind of thing. So it's 2 pi times, you flip 3 over pi, cancel, so it's 6. That means one full cycle is 6. Okay, I've written here 12 because they want us to draw over a 12-hour period. So I should draw a 6 here. So one full cycle will happen here and another full cycle will happen here. Alright, now what I'm going to do here is I want to transfer this to here, easier. You can do that in the O levels, okay? You do one round first. Okay, you know that there are 4 quarters of an egg, right? So I draw 1, 2, 3, 4. Okay, if this is 6, halfway is 3. Halfway, 1.5. So 1.5, this must be 4.5. Clear? Again, okay, I stop here. I do one round first. So let's do the one round. This is what graph? Cosine graph. But you must flip it. Cosine graph, if it's a positive cosine, right, you will quarter of an egg quarter of an egg, quarter of an egg, quarter of an egg, right? But because it's minus, so it doesn't start from here, it flip. Okay, don't understand, ask me, so it is like that, quarter of an egg. Okay, then the next one is here, next one is here, the last one is here. All right, quarter of an egg, quarter of an egg, quarter of an egg. Got it? You go by this quarter of an egg, quarter of an egg, quarter of an egg, quarter of an egg. Your curve, the shape will more or less be there. Okay. Now I'm going to do the second cycle. Again, I split it into two. That will be okay. Maybe go by this way easier. 1.5, 1.5, 1.5, 1.5. So this must be 7.5. This must be 9. This must be 10.5. This must finish it yet. Okay. So that's all. Okay. So quarter of an egg now we have to come where? Quarter of an egg, quarter of an egg, quarter of an egg, quarter of an egg. Okay, are we clear? So that's how you draw the then label it. Okay, that's how you draw the diagram. So you see, firstly, I must repeat this because many of you messed up. Okay, 110 here, center. Okay, then look at the amplitude, 30 up, 30 down. Okay, this minus means it's flipped later than we do. Get the period right. It's 2 pi. For both sine and cosine is the same as 2 pi over this number here. Don't mess up here. This t is by itself a variable. The number, whatever you see here, throw downstairs. Then you use calculator. You get the answer. Okay. You don't see any pi here, right? Then it's just 6, 6 here. Okay, then you can label this here, not a problem. Okay, but you label this here, right, is to help you to draw this accurately. Then after that, you can transfer down. You don't transfer down, actually, it's fine also lah. Okay. Now next step. The patient is considered healthy. No, it's considered health at rest. Health at risk. Sorry. When his blood pressure is above 125. Okay, so I set it to 125. Find the duration for which the patient is at health risk. Okay, now to solve this equation, I would strongly recommend that you somehow use AddMath lah, AddMath. Meaning you have a guideline. This is a trigo equation, right? Trigo ratio with an equation here. So AddMath means you must express it in equivalent form here. Is it now in sine, cosine, or tangent equals to a number form? It is not, right? So you must make the cosine the subject. So I try to make it the subject. Now it's the subject already. Okay, cosine or something. Okay, cosine or something is equal to a number. Alright. Now after this, I find the wait. In this case, in this particular case, right? Because my you see my what you call that? Domain is from 0 to 12. Okay, so next you check the domain. Okay, it's from 0 to 12, so I bear in mind that it's from 0 to 12. And then now I find my the mode must be radian mode. Alright, now you can just write this down somewhere on your paper and then you do the check, because in your exam, right, some of you never change to the correct mode. Some of you never check your domain. Supposed to be like in radian you use degree. Okay, so things like that. That's why it's good to do the AddMath. Okay, then now the next part is this. After you have found this, right, you want cosine to be negative. Where's cosine negative? It is here and here, right? Okay, meaning to say it is like that. Pi minus pi over 3. Then this is here. Okay, because this is pi, right? This is pi, and then this is pi over 3. So it's pi over 3 plus pi. Then after that you go one more round plus 2 pi, go one more round plus 2 pi. Then you can get these 4 answers. Now what is the significance of these 4 answers? If you were to look at the graph, it means that the answer is 2, 4, 8, 10, right? It means that at 125, above 125, if I were to draw a line here, right? 2, 4, 8, 10. Oh, so the duration where it's above, isn't it 2 plus 2 and that's 4? Okay, you know what I mean? When it's above the blood pressure too high, okay, too high, then he's in danger. So this guy, next time you be a doctor, right, you must know, 4 hours. You check whether my answer is correct or okay. Then let me know if the answer is wrong. Now next part here, last question already. Now what time? Oh, it's already 1 hour. Okay, the diagram respectively, and then you know that this DC is parallel to the x-axis. That means the gradient of this line, what they're trying to tell us here is the gradient of this line is 0 lah. Or in other words, there are a few things that they're hinting you, but just by saying this, because this is at the same level. So if this is 0, then if this is k, this must be k also, right? So this point D must be 0k. Do you agree? So that's one thing that they're hinting to you. That's the other thing that they're hinting to you. Okay. Given that B is equidistant from A and C, show that k equals to 8. B is equidistant from A and C. So same distance, they're trying to tell you this distance, this is the length here, same. So may I check with you, are you able to use the length formula? Yes. Why? Because there's only one unknown. Be careful when you apply the length formula. If there are two unknowns, right, you cannot apply the length formula alone. You have to have the length formula and another equation. One unknown can have one equation they can solve. Two unknowns, you need two equations they can solve. Alright? So what you do is you don't need no, then you get the answer. Of course, you reject this. Alright? So that's the first one. Why reject? Because based on the diagram, it has it's not at the it's not here, you see. Alright? Okay, now find the area. Okay, this area, I think you can find. So that's all. Now, the next part is on a line L is perpendicular to this, and so on and so forth. Okay, so what are they trying to tell us? They're trying to tell us that there is this particular line that is perpendicular to the line AB. AB produced means make it longer. Okay, and it's perpendicular to it, so it can be perpendicular like that, anyhow like that, right? But they say that it passes through the point C. So yeah, they're talking about this particular line. Okay, got it? Okay, find the equation of L, and this line is called L lah. Okay, very simple, because now we already have the K value. What is the K value? That's 8. With a point on the line, if we are able to find this gradient, we will know this gradient, and then we can find the answer, correct or not? So that's the whole idea. Find the gradient of this, find the gradient of this, ding dong dong, then you can get this line. Okay, very simple. So the answer is y equals to minus 2x plus 20. I write down here. Okay, now next part, the last part already. Last part, they say is that the last part? Yeah, I don't know where I threw the. Oh yeah, here. Okay. Yeah, if AB is the line of symmetry of this BCE, okay, so now AB is the line of symmetry. That means it's like a mirror line that cuts this BCE. BCE, then where's E? That's not in the diagram. You yourself have to figure out where the E is, okay? You yourself have to figure out where the E is. So the E has to be, because this is B, right? This is C, right? So E has to be here. Like that. Okay, so how do we do it? Very simple. You find this equation. Because you already know this equation, you find this equation. We got 2 points you can find. Then you get this point, right? That's the midpoint, right? Then you use the midpoint. Then you can find already. So that's the whole idea I show you here. Okay, I won't go through. I think it's very straightforward. Straightforward, but it's O-level standard. Okay, so if you don't know this, those who don't know this one, you better know. Okay. Okay. Thank you. Yeah. Thank you very much. That's all.